Hey guys, Dr. B, just a quick little video to give you a little bit more about the exam. Obviously you want to review your quizzes and whatnot online, so I've opened those up so you can see correct answers and all that kind of stuff, you know, checking your homeworks and all that. That's, in order to do that, if you want to look at more detail, you'll have to go to McGraw-Hill Connect website and log in that way to look specifically at what you got wrong. Some of you might be able to just re-click on the assignment here, but most you'll have to do that to see the feedback on the ones that you got right and wrong. So I'm not going to go down the list of all these things, but just to give you an idea about which ones might have more or less points. There's a fair amount of questions on exon activation, and you definitely want to know the genes involved in that. We talked about a lot of this stuff in class. The biggest thing, obviously, is acetylation and methylation, understanding how they relate to transcription and rates of transcription, etc. This part, the different types of non-coding RNA, is really just definitions of them, kind of what they do, couple like, you know, nothing crazy, but just generally what their roles would be. The CRISPR part's in red because that is also an open-ended part of the test. So you really want to be able to talk to, like, how did this start? And, you know, if you were given a diagram of, you know, a CRISPR-Cas with a guide RNA, what would that look like? And kind of how they work. So great, lovely, lovely. Again, talked about viruses. Definitely you want to understand phage replication, and of course the differences between lytic and lysogenic and whatnot. Then moving down the line, the rest of these things, obviously, I'm not going to go over each one. Very, very clear. DNA repair systems, you definitely want to spend a little time on those, so you are familiar with kind of how they work. These are all the ones we talked about the other day. Ames test, you can look up yourself. It's not hard. The very bottom of the part you can't see here, there we go. You'll be given a DNA strand, and I'll show you kind of what that looks like. So let me give you a couple questions from the exam so we can look at those. So here's a question that kind of gives you a relative level of understanding of what I'm looking for with X chromosome and activation. It's an important tool to understand how we can have gene silencing and chromosomal silencing. So you want to know this fairly well. And that's kind of the level of question. There's a few of them on X activation, but this is probably a harder one. Here's a little bit of a more difficult question. I don't want to show you some easy ones. Show PAR mutation, another word, obviously, that you should be familiar with. So again, just another question to look at. You guys also might get a question that kind of might look something like this. So, let me just get these fixed here. So there's a couple different ways that I could ask you this. One would be to just give you, like, here's a normal sequence, and then here's a mutated sequence of the same sequence. You have to find where the mutation is, and then you'd have to tell me what the RNA is, a messenger RNA, and the amino acids. So I can either do it kind of this way, where it's understood that if it's ATG, then that would be the strand of DNA that's not going to be used for the actual gene. So basically that means that you would then translate this. So therefore, if it was the RNA, right, if I were to just kind of do the RNA from this, because it's from the other strand. Remember, the other strand, by the way, is going to be T, A, C, G, G, T, you get the idea. And then obviously this is the strand that's going to be, therefore, translated into RNA. So that's going to be TAC, of course, codes for AUG, and then it's going to be CCA. You get the idea. So, if I'm going to tell you one way or another whether the DNA you're looking at is going to be the one that you're going to use directly to make messenger RNA, or whether it's going to be the other strand that you can't see that's going to be used to make messenger RNA. And if you get something that looks kind of like this, where the directions say that, you know that this strand is not the one that you're using to make the DNA from. It's the other one. And so that's why you need to take the opposite of the other one, which would give the AUG for mRNA. So you'll have a couple on that. This is a longer exam than you're used to in molecular than from genetics. This is like, I think it's like 70 multiple choice and 4 or 5 long answers. So it's a little bit more difficult, but it should be. You guys are getting pretty far along in the program. So hopefully that helped, and good luck.